Good morning, everybody. My name is Dr. Maggie Aderin-Pocock, and I'm a space scientist and a science communicator, and really happy to be joining you today. Hold it, that's not right. She's not me, I'm me. I'm Dr. Maggie, and I'm a space scientist and a science communicator. Very happy to be joining you today. And what I want to talk to you about is about my latest book, Am I Made of Stardust? Now, before I get into the book, I want to tell you a little bit about myself. This is a picture of me when I was a child, about 3 or 4 years old. And I wish I was looking epically up into the night sky, but I'm not. I've dropped some of my ice on the ground and I'm trying to pick it up before my parents catch me. Not the most glamorous start. But right from the get-go, I was excited about space. And all my life, I've wanted to get out there. I've literally been reaching for the stars. And what I want to tell you is that you should be reaching for the stars too, no matter what your stars are. My crazy dream is to get out there in space. Your crazy dream might be something totally different, but always have a crazy dream and see where it takes you. And one of my crazy dreams was having a Barbie doll made of me. I wouldn't have believed it. But because of the talks I do, speaking to people like you, Mattel actually made a Barbie of me. And this is me looking very, very excited about it. Now, when I was growing up, I always thought that astronomy was effectively done by white guys in togas. It was all about the Romans, it was all about the Greeks. I didn't hear about anyone else doing astronomy. So sometimes I thought, maybe why should I be doing astronomy? I'm a sort of a black kid from London. But it turns out I was wrong. Every culture across the world has been fascinated by what's out there. People have made up creation stories. People have built monuments. There's beautiful instruments called astrolabes made by the Arabic societies. And they have words of the Quran etched on their edges, but they've also got some amazing drawings on them. So art and science fused together. If you look, the oldest stone circle in the world isn't actually Stonehenge. There's a stone circle which is 9,000 years old, and it sits on African soil in Namibia. So every culture has been fascinated by the stars. So it's the heritage of all of us. Now, let's get back to the book, Am I Made of Stardust? And that is my first question that I want to answer. The simple answer is yes, but how do we know? Well, to understand this, we need to go right back to the beginning of the universe. We're going back to the Big Bang. We believe the universe started off as what we call a singularity, a tiny point in space which expanded out into the universe we have today. How do we know this? It's because when we look out into the universe, we see that everything is moving away from us. And so if you reverse time, we know it all comes back down to this singularity. I've got a little demonstration here to show you how it might work. This is a balloon with lots of galaxies on its surface. As I blow the balloon up, everything is expanding. The galaxies are moving away from each other on the surface of the balloon. So, excuse me, that's how we think the universe works. So, if that's how the universe works, what was around in the early universe? Well, when we go back in time and look and try to understand what was in the early universe, we think the main element around was hydrogen. Most things, everything there was hydrogen with a little bit of helium. So if hydrogen was around in the early universe, where did all the other chemicals that make up our bodies? If you look on this slide, you can see that about 65% of our body is oxygen. We've got quite a bit of carbon in there. We've got a little hydrogen, which might have come from the early universe, but where did all the other elements come from? To understand that, we need to look inside the heart of a star. So this is our local star, and what we're doing now is we're zooming straight into the centre of the star. Our star is absolutely massive. You can fit 1.3 million Earths into our sun. So our sun is absolutely massive. And the temperatures and pressures at the centre of our sun are huge. And what takes place is this process called fusion. This is when you get atoms coming together, maybe a hydrogen and a hydrogen to make a helium and a hydrogen to make something else. This fusion process makes all the elements that we have here on planet Earth. But we have these elements happening, but what is the reaction? Well, it can be described by an equation, E equals mc squared. It's an equation you might have heard of, and it was derived by Einstein, the very famous physicist. But it's a very simple equation. E is energy, which equals m, which is mass, times c, the speed of light. But it's not times c once, it's times c twice. C is incredibly large. It's the speed of light. It's actually 300 million meters per second. So for a very tiny amount of mass, you get huge amounts of energy. So if I take, for instance, this bottle of water, if we turned it into energy using the fusion process, this could probably power London for about a week. So with this fusion process, we're getting huge amounts of energy. And this fusion process makes the different elements that you find in you, me, and everything around us. But how does it go from the centre of the star to you and me? Well, to understand that, we need to understand how stars die. Depending on the size of the star will depend on how it dies. So stars, just like people, go through a life cycle. They're born, they live, and then eventually they die. When most stars die, it's because that fusion process has run out of fuel. And so the external pressure of fusion and the internal pressure of gravity wins. Now, for stars about 10 times bigger than our sun, what happens is that fusion process runs out, the gravity gets stronger and stronger and stronger, and eventually what happens is the star explodes. It's called a supernova, and it's one of the brightest things in the universe. We can see stars going supernova in other galaxies, it's so bright. So this is how all that matter gets spewed out of the star. That matter gets spewed out and it forms what we call a nebula, a cloud of dust and gas that sits in space. But nebula is where new stars are born. So out of the remnants of an old star, a new star is born, and it sucks up some of those elements that were made in the old star, and then new planets are formed, life is hopefully created, and that's how you and me were formed. That's why the stuff in us is the stuff of stardust. But remember, we're not just the product of one star. The stuff in us has probably gone through 2 or 3 stars. So we're not just stardust once, but we're stardust cubed. We're made of special stuff, and each and every one of us is special in our own right. Okay, next question. Can I sing in space? Well, to do this question and to tackle this question, I want us to join in and sing one of the classics of sort of a space and astronomy, Twinkle, Twinkle, Little Star. So I want us all to sing it together, but as we sing, I want you to put your hand on your throat and see what you feel. So I'll get started. I'm a bit croaky, but I'll get started here. Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. Okay, tell me what you felt. When I was touching my throat, I could feel a vibration. And the vibration comes with something called our vocal cords, which sit at the back of our throat. As our vocal cords vibrate, we make sounds, and so it can go up or down, but they need to vibrate to actually vibrate the air particles, and that's how we hear sound. So that's our vocal cords at our back of the throat. So can I sing in space? Very much depends on what your environment is in space. On the International Space Station, you'd be fine because you've got an atmosphere around you. You've got air you can breathe, you can take it into your lungs, and you can let it out. If you're in a spacesuit outside the International Space Station, once again, you're fine. But let's say you don't have a spacesuit, you're in the vacuum of space and you try and sing. Well, to demonstrate this, empty all the air out of your lungs and now try and sing. Twinkle, twinkle. Okay, it just doesn't work. You need that air in your lungs to vibrate your vocal cords so you can make the sound waves. So if you're out in space with no spacesuit, you can't sing. But if you're out in space with no spacesuit, you've probably got other things to worry about, like the temperature is bitterly cold. Also, there's no air to breathe, so you're probably going to pass out. There's lots of other things to worry about. I don't think you'll be thinking about singing. But now, let's think about another situation. I'm on another planet, not Earth, but a planet that has a different atmosphere. Let's say Mars, for instance, where there's lots of carbon dioxide. Again, we can't breathe in carbon dioxide and actually utilise it for energy. But let's say I'm on a planet where the atmosphere is mainly made out of helium. I've got a demonstration here. How will I sound if I have helium in my lungs? Well, let's give it a go.
Twinkle, twinkle, little star, how I wonder what you are.
So this will wear off in a minute. But what's happening is, because I've got a different gas in my lungs, as it passes over my vocal cords, they vibrate in a different way. So I sound quite different. So depending on the planet you're on, if you can breathe the atmosphere, even if it's sort of a similar atmosphere to us, If it's made up of different gases, then you'll sound very different. So you can sing in space, but depending on where you are, you might sound very different. Okay, one of my favourite questions, is there life out there? And the question is, we don't know. The only example we have of life out in our universe is right here on Earth. We have life in the air, we have life on the land, we have life in the waters, but we haven't found life anywhere else. In the past, we thought the only way you could actually find life was to look at what we call look for planets in what we call the habitable zone or the Goldilocks zone. This is where you're not too close to your star, so it's too hot, or not too far away from your star, so it's too cold, but you're in the position which is just right to have liquid water. One of the things that all life on Earth seems to have in common is the need for liquid water. So that's where we've been looking for planets, where it's just right, in the Goldilocks zone. And it's quite interesting, if you look at a planet like Mars, we used to think that it was in the Goldilocks zone. We know that on the surface of Mars, liquid water used to run over the surface. We can see old river tributaries, we can see boulders formed by water. But Mars lost its water. And we think that Mars lost its water because it lost its magnetic field. Here on Earth we have a lovely magnetic field which protects us from particles streaming off the sun. Now Mars is smaller than Earth, and so the magnetic field is caused by a liquid core of iron which moves around and creates this magnetic field. Because Mars is smaller than Earth, we think it used to have a magnetic field, but it lost its heat, and so that core solidified, and so it lost its magnetic field. And so now Mars, as we know it, is sort of a dry and very sort of forbidding place. But one of the things we're trying to find out is, did Mars ever have life? Now, if life was on Mars, it lived 3.5 billion years ago. So trying to find evidence of life today is very, very challenging. But we keep looking, and we send rovers to the surface of Mars, a number in the past, and this is a rover called Fetch. It trundles over the Martian surface, but it isn't actually taking samples and testing them. What Fetch does is it picks up samples from the Martian surface gathered by other rovers, and it collects them, and what it intends to do is to bring those samples back to Earth. Bring those samples back to Earth so we can test them in our big labs and get a true understanding if there was ever life on Mars. It's quite a challenging thing to do, but it's underway at the moment, and we hope to have the samples back on Earth in the next 10 years. Now, it's quite a dangerous thing to do as well. We need to be very careful. When we send probes to Mars, we make sure that we don't contaminate Mars. And when we bring samples from Mars to Earth, we once again need to make sure we don't contaminate the Earth. So we're being very careful with this. One of the new exciting ideas, though, came out by looking in the deep oceans of the Earth. This region is called the Mariana Trench, one of the deepest parts of the ocean here on Earth. If you look deep down, the Mariana Trench is 11 kilometres deep. 11 kilometres deep into the ocean. And when you're down here, not even sunlight can penetrate. It's just too far away from the surface. So because of that, we thought that no life could live down here. What life can live with no sunlight as sort of a starting point for an ecosystem? But we were wrong. When we sent probes down there, we found life was thriving down there. They were living off the thermal vents that will bubble up from the hot core of the Earth. And so if you could have life there, it means there are other places we can look for life here in our solar system. And so now we're looking for life on places like the Saturn's moon Enceladus. Now, Saturn's moon Enceladus has an icy crust because it sits a long, long way from the sun, so it is incredibly cold. But because of the gravitational force of Saturn on this moon, we believe underneath the icy crust there's liquid water. And we've got evidence of this because every so often some of that water will spew out through vents in the surface. And so there's a possibility that underneath the icy crust, in the liquid ocean beneath, there could be life. Because there could be thermal vents, actually, sort of due to the gravitational force of Saturn, creating sort of things, hydrocarbons, which animals or some sort of creatures could live off. So in the future, that's what we want to do. We want to send probes to this icy moon and see if there's life below the surface. So we've been looking for life in our solar system, but now we have the opportunity to go even further afield. We're looking for life beyond. We're looking at what we call exoplanets. If you look up at the night sky, you might see 1,000 different stars. Each one of those stars is a sun like our sun. And what we're doing for the first time is discovering planets going around those stars. Now, in our whole galaxy, there are about 300 billion stars. And what we're finding now is most of those stars seem to have planets going around them. Now, planets are very hard to spot. Stars, because of that fusion process, they give out light, so they're easy to see. But planets don't actually create light. They're not doing fusion. And so to see a planet here in our solar system, what happens is light comes from the sun, it's reflected off the planet, and then it falls into our eyes, which I think is quite magical. But if that star is trillions of kilometres away, the light hitting the planet is just too faint to see. So we use other techniques. One technique is if you've got a large exoplanet going around a star, then the star wobbles by a small amount as the planet goes round it. And we can detect that wobble because the star's shining brightly and see that there's an exoplanet there. But our favourite way of detecting exoplanets is using what we call the transit method. That means that as a planet goes in front of the star, some of the starlight is obscured by a small amount, and we can actually look at that obscuration and work out that there's a planet there going past that star. And we can tell a lot about the planet, its size, its orbit, and many other things as well. Also, if that planet is in the right orientation, we can actually analyse the atmosphere of that planet. As the starlight passes through that atmosphere, we can work out what chemicals are in the atmosphere of a planet trillions of kilometres away. And now, using this technique, we're finding many Earth-like planets out there. Planets with liquid water and water vapour in their atmosphere. So we're quite confident of that one day finding life out there. My third question is, will I ever get in space? Will we ever get in space? And will we ever reach the stars? This has been my crazy dream all my life. I've always wanted to get out there. It started with watching things like The Clangers, then it was enhanced by watching things like Star Trek. In Star Trek, I had two favourite people. First one was Lieutenant Uhura. She was the communications officer, an amazing woman. And when I was growing up, there weren't many black people on TV, so seeing Lieutenant Uhura just made my heart sing. But the captain of the ship was Captain Kirk. He was the captain of the Starship Enterprise. Now, Captain Kirk was played by an actor called William Shatner. Now, William Shatner played the part of being a starship captain and travelling through the stars, but he never actually got a chance to go into space himself until about 2 years ago. This is a video of the actor William Shatner in space. And you can see he's absolutely mesmerised by it. He's looking out of the window, seeing the curvature of the Earth, seeing our planet in front of him. And he keeps on saying, I don't believe it. I can't believe this is happening. So he played a starship captain all that time and finally got the opportunity to go into space. Now, one day I'd like to go into space, and I think I've got time, because William Shatner went into space when he was 90 years old. So I've got a few years yet, I can still make it. And at the same time on this flight, the youngest person to ever go into space, a chap who was just 18, also went into space. So they had the oldest person in space and the youngest person in space, both at the same time. And in the future, NASA says that many of us will be going into space. In fact, NASA are trying to send people back to the moon with a project called Artemis. So far, only 12 people have been to the moon's surface, and it's been 12 white guys. And so NASA is saying, this isn't right. We need to send other people to the moon. We need to send people from other ethnicities. We need to send women to the moon, because no woman has been to the moon yet. I keep on telling NASA, they need to send me to the moon. They're not returning my calls, but hopefully I'll get there one day. But NASA also say that the first person to actually step out on Mars is alive today. And we're talking about moon bases, having people living on the moon. The moon is an incredibly hostile environment, with temperatures ranging on the day side from plus 150. I cook cakes at home at 150 in the oven. So temperatures as hot as an oven, down to minus 150, colder than Antarctica. And also a hostile environment because there's no atmosphere to protect the astronauts. And so radiation from the sun, meteorites from space can come and crash into their habitation. So there's all sorts of challenges facing a moon base, but in the future we might have them. Slightly less challenging is Mars. My retirement plan is to retire to Mars on a one-way trip, so go to Mars but maybe never come back. But we're trying to think how we might build a base on Mars as well. And as I say, NASA says the first person to travel to Mars is alive today. So it really could be you. And if you go, come back and tell me, because I'd love to find out more about it. But crazy dreams do come true, because a few years ago I got to meet one of my heroes. This is a picture of my daughter. She's carrying a clanger, one of the other things I love, and she's sitting next to an actress called Nichelle Nichols, the actress who played Lieutenant Uhura. It was a wonderful moment for me to meet my heroine. But I mentioned my crazy dream is to actually get out there and visit one of those exoplanets, just like they did on Star Trek. And very exciting news, we found that there's an exoplanet going around our next door neighbour star. I mentioned there are 300 billion stars in our galaxy. Well, it turns out that our next door neighbour star is called Proxima Centauri. And we know that there's an exoplanet going around Proxima Centauri. It's about the size of Earth, but we don't know exactly what it looks like, so this is just an artist's impression. But out there is an exoplanet, and it could possibly have life on it. The problem is, that exoplanet and that sort of star system is 4.28 light years away. And in kilometres, that's 40 trillion kilometres away. It's an awful long way away. And if we use current technology to actually travel out there, that's travelling at 16 kilometres a second. That journey of 40 trillion kilometres is going to take 76,000 years. That means my crazy dream of actually reaching the stars seems really crazy. But when we're faced with crazy ideas, as scientists, as engineers, as people working in STEM, we try and find solutions to the problem. And one of the people who was trying to do that was the late, great Stephen Hawking, an amazing physicist who died quite recently. But he was championing a new project called Breakthrough Starshot. With Breakthrough Starshot, we want to use a new sort of technology. The technology is called a solar sail. A solar sail is a sheet of metallized plastic that sits in space, as you can see here. Very, very thin. And just like a ship on the ocean, we want to use winds to blow that. So on Earth, we use winds to blow ships along. With this ship, we want to actually use light. We want to use lasers to accelerate this solar sail to 1/5 of the speed of light. If we can do this, and we can use this bank of lasers, now these lasers are going to take a huge amount of power. We might have to turn the power off of a city of Sheffield for a day just to fire these lasers. But when the lasers hit the solar sail, they'll accelerate that solar sail to 1/5 of the speed of light. If we do that, it means that that journey of 40 trillion kilometres, it won't take 76,000 years. We could do it in just 20 years. Now, I need to have a few caveats on that. The probe we can send can weigh no more than 1 gram. And once it sails past the exoplanet, it will just keep on going into space. We can't slow it down. But in the next maybe 30 years, we might be able to get the answer to, is there life out there? And we might actually have pictures to support that argument. So thank you so much for listening. And remember, keep asking questions. That's what life's about. That's how that's what makes the world a better place. And always reach for the stars. My stars happen to be stars. Your stars might be something totally different. But think big and think crazy and see where it takes you. Thank you so much for listening. Okay, now let's go on to the questions. I have a pot here full of questions, so I'm going to shake them up and grab a few questions and see what we've got. Okay, this is the first one. So this one, I think, this is from Archbishop Isley Catholic School in Birmingham. And how do we even know what stars are made of to compare them with ourselves? That's a good question. So we have an understanding of what stars are made of because we can analyse the light from stars. Oh, we can analyse the light that's coming from the stars. And if we do that, we can actually work out the chemicals that are in stars. If you go back many, many years ago, people thought the sun was just a lump of coal burning brightly. But when you look at the amount of energy that comes from the sun, you realise that coal wouldn't give us that amount of energy. And so we were able to work out the things. In fact, there was a fantastic woman who worked out that it was a fusion process taking place in the star because of all the temperatures and pressures. So even though we're remote from things, we can analyse them by looking at their light and looking at the sort of radiation they give. Okay, let's go for the next question. I've got one here. And this is class 7.6 at Somervale School near Bath. If you had an opportunity to time travel, what era would you travel to? And what one item would you take with you and why? I love that question, thank you. I've always thought about time travelling. And the thing is, if I was time travelling, I'd want to go everywhere. I'd want to go back and meet people like Galileo. I'd want to go back and see when the stone circle was first built in Namibia. But I'd also like to go forward in time. There are so many questions that we haven't got answered. One question, for instance, is we don't know what 94% of the universe is made of. We know what 6% of the universe is made of, but the other 94% we don't know. And so maybe one of you will come up with a solution, because as scientists today, we're stumped. So we're looking for answers. So if I go into the future, maybe I'll find out those answers. And also, what I take with me, I take my daughter, because she's my inspiration in everything I do. And in the past, she said that I'm a space scientist and she's a space artist. So if we travelled through time and space together, then we can sort of journey to sort of the other stars using current technology, which would take 76,000 years. But if we had a time machine, we could get there much quicker. And she'd do the art and I'd do the science, and we'd have a lot of fun together. Okay, I'm going to take another question. Ooh, look, this was a big one. Okay, what have we got here? So it says, at Paget High School, Burton-upon-Trent, who or what motivated you to develop an interest in science? So I think I've been very lucky that I've had lots of different motivation. People have really inspired me. As a child, I heard about, there was Lieutenant Uhura, there was the Clangers, but there were also people like Yuri Gagarin, the first person to travel out there into space. And later on I found out that we share a birthday. We were both born on the 9th of March. Some fantastic women who've done brilliant things in science. Someone like Jocelyn Bell Brunel, Gladys West, who actually looked at the shape of the Earth to make GPS better. So there's fantastic role models out there. And and my mother and father too, and other amazing role models. Okay, what else have we got? Okay, King Ely Junior School, Cambridgeshire. And how far away can you travel from the Earth's surface? Ooh. Well, this is an interesting question. Humans, as humans, we generally sort of go as far as the International Space Station, and that's only about 300 kilometres up above sea level. Now, some humans have gone as far as the moon, which is sort of travelling sort of a bit further. But in terms of probes, we've sent probes to places like Pluto, the dwarf planet. Now, these probes, so Pluto sits about I think it's about, over 1 billion kilometres away from Earth. So that's about as far as we've sent things. But we haven't, but there are also 2 probes called Voyagers, Voyager 1 and Voyager 2, launched in the 1970s, and they've actually left our solar system. So, but they've got nowhere near to our next door neighbour star. It will take thousands of years for them to, actually millions of years for them to get to our next door neighbour star even. So we've sent things to the edge of our solar system, but the universe is very, very vast. As I say, ours is 1 star out of the 300 billion, and in the whole of the universe, 200 billion galaxies. There's a lot of stuff out there. Okay, more questions from the pot? Okay, perfect. What else have we got? So now I've got Long Ditton St Mary's School in Surbiton. You do a lot of different jobs. Which one do you like the best and why? And it's quite right, I do a lot of different jobs. I'm an author, I work on TV, I work as a space scientist, I worked on the James Webb Space Telescope. But what I do is a lot of public speaking. So things like this, speaking to people and telling them why I'm so excited about everything that's out there. And out of all those jobs, I think this is my favourite. I love sharing my passion of science and space and astronomy with as many people as possible. Now, on the call today, I think there were many, many thousands of kids and people listening. And so this is one of the definite highlights for me, speaking to all those different people about what I'm really excited about. So I think that's definitely my favourite job. Okay, I think we've got time for a few more. What else have we got? Holy Cross Catholic Primary School in Wamley, I think, a Sutton Coldfield. Or is it possible to escape a black hole? This is one of my favourites. Black holes are fantastic objects that are out in space. When people first came up with the idea of black holes, people thought, you're crazy, they can't exist. Now, I mentioned that stars have a life cycle. So they're born, they live, and then they sort of die. Different stars die in different ways. Our sun, for instance, will expand outwards and get bigger and bigger and bigger, and gobble up Mercury, gobble up Venus, and eventually gobble up Earth. Don't panic, not for another 4.5 billion years. But other stars, which are maybe 20 times the sort of mass of our star, will actually go what we call and turn into a black hole. That's because they have so much gravity, because they're so massive, that what happens is, when the fusion process runs out and they stop fusing things together, the pressure of the gravity pulls the star in, and it pulls the star in, and it pulls the star in, you almost end up with a singularity, like the start of the universe. And what happens is, the gravity is so strong that not even light can escape, which is why we call it a black hole. Now, if you're actually going around a black hole, you're okay if you don't go inside what we call the event horizon. It's one of the things I cover in the book. So a black hole is a dense sphere in space which you can't see because it doesn't reflect light. But around the black hole is an imaginary line called the event horizon. If you sort of go past the event horizon, you're fine, and we can see stars swirling around that. But if you go inside the event horizon, that's when you're in trouble. Now you can no longer escape. And if you go feet first, for instance, you might get what we call spaghettified, which is actually a scientific term for what will happen to you. So if you go feet first, what happens is the gravity on your feet is much stronger than the gravity on your head. So you get elongated, just like this piece of paper, into a string of spaghetti as you fall into the black hole. Now things go into the black hole, but as there's conservation, there's laws that say that if things sort of go in, they can't just disappear. So perhaps if you go into a black hole, you come out in what we call a white hole somewhere else. So we don't quite know what happens in a black hole, but if you go inside the event horizon, then there's no escape. Okay, let's go for another question. I've got two here. Here we go. So this is King's Prior School on Tyne and Wear. What inspired you to write your book, and how long did it take you to write? Okay, so I need to confess here, because the book, I was inspired by doing talks like this. And when I do talks, people often ask me questions. And so I took my favourite questions from all the ones I've been asked over the last 18 years. And I think I've seen about 450,000 people. So I took my favourite questions and put them in the book. So maybe one of these questions might appear in a book in the future. So I put those questions in a book, and that's why I wrote the book. And but one of the things, it did take me quite a long time, because I have a condition called dyslexia. I found it very hard when I was at school, because with the dyslexia, I find it hard to sort of to do writing, to do spelling. I still can't spell today. But I also see dyslexia as my superpower. Although I find writing hard, it makes me think differently. I'm logical, I'm creative, and so by being dyslexic, it really is my superpower today. So it took me quite a long time to write the book, about a year, but it was definitely worth it, and I do hope you enjoy it. Thank you so much for listening. And oh, I've got a question from over here. What's the question?
Hoppingham Primary School, what is the size of the biggest star you are aware of?
Yes. Okay. So what is the size of the biggest star I'm aware of? Now, I can give you sort of ballpark figures. Now, our local star is the Sun, and it's about a middle of the range star. But do remember, you can fit 1 million Earths into one Sun. So that's pretty big. Now, out there are stars which are over 1,000 times the size of our Sun. And so you can actually go for a journey and look at smaller stars and bigger stars. Big stars which are burning blue because they have so much energy, they're giving out lots of blue light. So there are stars of sort of well over 1,000 times the size of our Sun. And our Sun is pretty massive anyway, so there's some pretty glorious stars out there.
In Victor Primary School, Year 5, could animals live on other planets?
Ah, this is one of the questions I try and answer in the book. Now, at the moment, we do... In the early days of space, we did put animals in space. So the first animal to go out into space was actually a dog called Laika. It was sent up by the Russians, and it was like a sort of a test to see if creatures could live in space. Unfortunately, Laika was a stray dog that wandered around the streets of Moscow, and they chose Laika because she was very calm under pressure, and they thought she would be the ideal animal to go into space. Unfortunately, Laika went up into space, but she never came back down to Earth. But she was sort of a test run before we sent humans, like Yuri Gagarin. But in the future, so at the moment, we don't really send animals. Getting people and things into space is incredibly expensive. So we generally focus on humans and satellites and things like that. But in the future, where I can imagine a future where people are going to space for holidays and things like that, then I think in that future, you'd be able to take pets too. The environment that a pet needs is a similar environment to what a human needs. So I can imagine sort of doggy spacesuits in the future. So if you want to run around the moon's surface, the dog would have to wear a little spacesuit. So yes, I think this will definitely happen in the future, but it's not something we do at the moment, just because it's so expensive.
Could you send a camera into a black hole? St. Catherine's, Bexleyheath, yes.
So St. Catherine's, this is a lovely question. And the problem is, once again, if you sent a camera into a black hole, if it's one of these medium-sized black holes, the camera would get spaghettified, so I think it would get very distorted. And also, any signal that the camera is trying to send back to us won't be able to escape the gravity of the black hole. So you'd be able to send a camera in, but you wouldn't be able to get any information out. A couple of years ago, we were very excited because we actually took an image of what we call a supermassive black hole. So there are black holes where sort of large stars collapse in on themselves. But what we're finding is that at the centre of every galaxy, there is a super massive black hole. And we're talking about sort of, millions of masses more than the sun. So massive black holes. And a few years ago, we were actually able to take an image of this super massive black hole. Because you can't see the black hole. But what you can do is things outside the event horizon, they leak their matter into the black hole. And that matter gives out radiation. So we're able to see sort of something sort of blurry in the centre, and then all this radiation leaking sort of around. So if you set a camera into the black hole, it won't be able to send any information out, but we can see black holes from afar and actually sort of try and understand what's going on with them.
Do black holes have names? Darwin, Iverson, Primary.
Ah, that's an interesting question. And yes, I think they do. We have a sort of convention in space. If you look at sort of the planets of the solar system, so we've got Venus, Mercury, Mars, they were all named by the ancients. So they were generally sort of talking about stories of Mars, the god of war, and things like that. But now we have naming conventions. So if we find a black hole, if we find an exoplanet, we have a very specific naming convention for them. And so yes, because objects are like black holes and we can detect them in space, we do actually name them, but they usually have very boring names. Now, one of the things that we're hoping to find in the future is another planet. So we have the 8 planets of the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. And in the future, we hope there might be another planet. We call it Planet 9, which we think is out there, but we haven't detected it yet. And if we do detect this planet, there'd probably be a naming convention where we'd actually open it up to the public and ask them to name it. When Pluto was discovered, it was actually named by a girl called Bunny. And as there was a competition and she came up with the name. And it wasn't named after the Disney character. It was actually named, I think, after a Greek or a Roman mythical creature. So sometimes you might get to name a planet in the future.
Hugo and Malvern Parish would like to know about whether any books or other objects have been taken out into space.
So it's quite interesting because I've met quite a few astronauts. I want to be an astronaut myself, so I'm very jealous when I meet them. But I meet lots of astronauts and they're fantastic people. But one of the things they tell me is that they're allowed to take a few things with them and a few extra things. And so, for instance, Neil Armstrong, he had a daughter who he lost. And the story goes that he actually took a bracelet from his daughter and left it on the moon's surface. So you are allowed to take a few personal things. I think some people do take books. Chris Hadfield took his guitar. I was playing in space. So different people take different things that mean something personally to them. So you've got your food allowance and your clothes and things like that. But you're also allowed to take a few personal things. And if I was able to, if I couldn't take my daughter, I think I might take, I've got a little doll that looks a bit like my daughter. I might take that with me. But I prefer to take my daughter. So we'll see if we can do that instead.
Onslow St. Audrey Secondary School. Is Pluto still classed as a real planet?
Yes. Pluto's a bit embarrassing, really. So Pluto was discovered in the 1920s, and I said the name Pluto was given to Pluto by a girl named Bunny. But Pluto is actually smaller than our moon. Actually, if you put Pluto and its biggest moon, Charon, you can put it across the United States of America. So Pluto is very, very diddy. And in fact, I think we found Pluto by accident. Now, the problem is, if we say that Pluto is a planet, then all the other small bodies in our solar system will have to call planets too. And so I mentioned you the 8 planets of the solar system. You kids at school will have about 20 planets to name. And so we thought, no, this just isn't good enough. We need to have a clear demarcation. We've got the planets, which are sort of big and go round the sun and things like that. Then we've got other bodies that go round the sun. And things like Pluto and Ceres, and there's a few others, about 5 or 6 others, we call dwarf planets. And so one of the problems is we found sort of objects which were bigger than Pluto, and so we would have had to call them planets too. So we decided that we'd have a cut-off. So if you're bigger than a certain size, and if you do certain things as you go around the sun, then you'll be called a planet. And then for everything else, if they're of a reasonable size, then they'll be called a dwarf planet. So Pluto, unfortunately, is a dwarf planet. But I've met some guys who want to change that. They sent a probe to Pluto when it was still a planet, and it took 8 years to get there. And by the time it got to Pluto, Pluto was a dwarf planet, and they were a bit cheesed off about that. So there are some people who want to make Pluto a planet again, but it is actually a dwarf planet. And I think it makes sense that it is.
How long will it be until Earth ends from our end?
Yes. Okay, don't panic. One day the Earth will come to an end, and that's because of our sun. What will happen is, as I said, yeah, stars go through these life cycles. So they're born, they live, and then they die. Now our sun, as I mentioned, will actually get bigger and bigger and bigger and expand out into the universe. First, it will gobble up Mercury, it will gobble up Venus, and then it will gobble up Earth. Now, this isn't going to happen for about 4.5 billion years because the sun is about halfway through its life. So it's got another 4.5 billion years to go. But I think by then, we will be living outside on other planets. We would have travelled to those exoplanets, found other Earth-like exoplanets. So then we won't be worried about Earth. We're talking about 4.5 billion years. And a billion is a very big number.
What is the biggest star we know of, Caroline?
Caroline. Now, so I'm trying to, because there's Vega, which is much bigger than Earth. I don't actually know the name, I can't remember the name of the biggest star that's out there, but it is much, much bigger than the Sun. It's thousands of times bigger than the Sun. And so it's lovely. But when you look out into our galaxy, the Milky Way, or even beyond to other galaxies, there are some amazing stars out there. Stars come in different shapes, sizes, colours, depending on where they are in their life cycle, depending on what the fusion process is happening within them. But yes, there are stars which are thousands of times bigger than our sun, and they're out there, and they probably have exoplanets going out there, going around them, and in the future maybe we'll detect more of them.
British School of Milan. I understand that the universe is always expanding, but from what is it expanding? What is the material?
Ah, so when we talk about sort of the universe expanding, it is the very fabric of the universe that's expanding. So I mentioned the Big Bang, the universe sort of starting with a singularity. And it's this singularity. Sometimes people ask me, so what is it expanding into? The thing is, we don't know. In the past, I would have been sort of very smug about it and said, well, the universe, when the universe was created in the Big Bang, space, time, and all matter was created at the same time. So you can't say what happened before time. But now we're playing with ideas that the universe might be embedded in another universe, maybe something like the multiverse. And so we don't really know what the universe is expanding into, but we do know that the universe is expanding outwards. Now, when you look at sort of the end of the universe, or how the universe might end, it could just continue expanding outwards and outwards and outwards, and the energy levels will get lower and lower and lower, and the stars in the night sky will blink out as the universe just expands. So that's one way. There is things, I mentioned that we only know what 94% of the universe is made out of. We know that this matter is there. We call it dark matter and dark energy, but we know it's there because it has a gravitational effect, but we don't know what it's made of. If there's enough of this matter, it might be that the universe is expanding at the moment, but given enough time, the universe might collapse back in on itself. So we know the universe is expanding because when we measure and do something called spectroscopy, we can see that everything is moving away from us. But in the future, we don't quite know what's going to happen. And it very much depends on this dark matter and this dark energy, which we know so little about, which is why I'm looking to inspire the next generation of scientists and sort of STEM practitioners, science, technology, engineering and maths, because we need help, because we're a bit stumped. So yeah, do come and join us because it's really good fun.
Year 6, Woodstone Primary School. What is the loudest noise in space? Was the Big Bang silent?
Very interesting question. Now, one of the things, there was a film which I watched when I was actually, probably I was a bit too young to watch it, but it's a film called Alien, and the tagline for Alien is, "In space, no one can hear you scream." And I thought, oh, it's absolutely terrifying, but it was a brilliant film. It was called Alien. But now, the problem is, I mentioned earlier that, can I sing in space? As I said, if you're in an environment like a spacesuit or the International Space Station, yes, you can sing. But you're out actually in space, then there's no air to carry the sound waves. We hear things because our vocal cords, you can hear my voice because my vocal cords are vibrating as air comes from my lungs and passes over them. So they vibrate the air molecules, the microphone's picking that up and transmitting that to you. But we need air for sound, or water, or some medium to carry the sound. Because the space is a vacuum, there's no way to carry the sound. So the Big Bang would have probably been silent because it was in a vacuum. If I did scream in space and I didn't have a spacesuit, no one would hear me. So it's quite interesting because when you watch sort of science fiction films, you do have your shh of the spaceship and whoosh. But in actual fact, if there was a microphone in space and a spaceship went past, you wouldn't hear it at all because you can't pick up those sound waves. But if you had sort of silent spaceships, people would feel it was a bit weird. So we've actually sort of given them sound. But yes, in space, yes, you literally can't hear someone scream.
way primary school, what did you do before becoming a scientist?
Well, it's funny because I would say that I was a scientist right from the get-go. Because I don't know, maybe like some of you, I was always asking questions. And asking questions is so important because that's what it is to be a scientist. But before that, I actually went to school, and I found school quite hard because I went to 13 different schools. And with my dyslexia, I was actually put at the back of the class. So I was thought of as a bit dumb. But I was lucky that I got lots of help and support. And so I was able to get my 10 GCSEs, 4 A-levels, and then go to university. But after I'd done my GCSEs, I did start focusing on science right from the get-go. So I did my A-levels in physics, chemistry, biology and maths, and then went on to university to do a degree in physics and a PhD in mechanical engineering. So as soon as I could be a scientist, I became a scientist. And that's because I've got this crazy dream of reaching the stars and getting out there. And I knew it's science that gets people into space. And so that's why I pursued that dream. So I would say I was a scientist right from the get-go. So think big, think crazy, and reach for the stars no matter what your stars are. Thank you so much for listening.